Hello, hello, hello. Okay, cool. That works. So, let's pick up where we left off. So, in the last live stream, I was showing you how to get distances, calculate distances using a haversine formula, or I was basically tidying up the formula and showing you how you should format code for production. Now I'm going to move on to the next task, which is filtering on house types. So that shows you my screen. It does. Yeah, so if this is the first one you're watching, the point is this. I've got a synthetic house data set that I've made up in a previous live stream, and I'm using it now to practice making a basic recommender system. And I'm at the point where I'm starting to extract features from the house data. So you can see I've got the latitude of the house, the longitude, the house type, the price of the house, the number of bedrooms, number of bathrooms, neighborhood quality, house condition, crime rate, garden size, and then some house keywords, which is some spoofed large language model keyword extraction data. So it's like a keyword extraction data set, as if each house had some comments attached to it, and I'm extracting from those comments keywords related to the house. So the first thing I did was calculate the distance using latitude and longitude, and the next thing I'm going to do, I'm just going to go along the line, is look at house type. So with house type, this is an example of a nominal category, which is to say there's no definite order in the category, basically. It's all subjective. So if you prefer a terraced house to land, terraced is more important to you than land. But if you want land and you don't want a terraced house, land is more important to you than terraced. There's no obvious order. A very common one that does have order is something like freezing, cold, lukewarm, hot, boiling, etc. Like those words have an obvious order going up in temperature. And you should be able to see, just check my screen, yeah. You should be able to see, for example, we've got crime rate, low, medium, non-existent, high, very high. Like these things have a natural order to them. Okay, so that's one thing. Yeah, so that's just the difference between a nominal and an ordinal categorical variable or feature. So what this means is I can't really extract anything from this apart from the fact that the user presumably has said they want to see different types of house. I suppose land is not really a house type, but whatever, property type, whatever you like. Yeah, so they will have said that, and so I can filter the data set based on what they've said. Now, because this is actually very easy, so I'll just show you how it's done. So if I just reload the house data set and I just get up house type, oops, should be house data. Yeah, so you can see I've got these various types, and if I say dot let's just say the user has said they're only interested in user house types. Let's say they're only interested in terraced. I can say house data dot query. Sorry, I don't know. House data dot query. That's why I do that. house type in. Oh, how do you do this again? Is it something like this? See if that works. Okay, so yeah, you can see that I've split it down now to just the terraced houses. So if I were to do this and then say house type dot value counts, you can see I've only got 7,000. I've got one example, one house type terrace that's got 7,569 examples. So if I print that, I can then also print house data house type dot value counts, and we can see instead we've got terraced, flat, semi-detached, detached, bungalow, land, park home. We've got all these examples, but I've whittled it down to just terraced using this query. Now, if you also watched the last one, you would have seen that you can actually profile this code and you can see how fast this is. So prun-s cumulative. Now this is called a cell magic in Python Notebook, and it allows you to, well, basically do reasonably complex things in a very short little command. And this is basically saying profile run, P for profile run this cell, and then rank it by the cumulative amount of time spent in each function call. And you can see that this took 0.013 seconds. If you watch my previous live stream, you will have seen that I actually did like a very large NumPy calculation in less time than this. So whilst it's not crazy, it's still 130 milliseconds, which is a bit, I don't know if that's very good. And so what this live stream could potentially be about is just trying to find a faster way to do that, trying to find a faster way to run this query. So let's see what ChatGPT thinks. And if you're not using ChatGPT, you really should. It's great. Really good at answering sort of questions like this. Using it's really quite efficient for filtering rows, especially with Boolean indexing. Okay, so we've got a few options here, and this is why it's so good, because this is stuff you might think about, like, oh, I want to vectorize it in NumPy, but how do I do that? And it's just giving you like a little bit of code there, and we can just come straight in here and we can see if it's good or not. It's a bit annoying when you have this output, but basically this is what we're trying to beat. So let's just say .130 milliseconds. That's what we're trying to beat. Just run that again. And let's set a markdown cell and say I mean, obviously, if you don't really care about speed, you would just stop here because this is a really nice one-line way of doing it. But if I'm thinking I want a user to be able to basically send off like a couple of queries every 10 seconds or something, if each query is taking 130 milliseconds or whatever each time, that's a lot of time. If there are like 1,000 users using the system, that's a lot of time. You're really clogging up the system. So ideally, we want to reduce that to make the query much faster. So if we do this, just see if this works. Okay, so is that the same? Oops. Yeah, so it looks like it did the same number of rows at least anyway. Let's try prun on this as well. Okay, so it's faster. Okay. If we turn that back on. Okay. So let's add some markdown here. In fact, actually, I don't like spaced out that is. Does that look better? Yeah. Cool.